So hi, today problem is 3702 longest subsequence with non-zero bitwise XOR. So what is the problem? We are given an array of numbers, and let's understand. We are given an array of numbers. For example, nums is equal to 1 2 3. Okay, so we have to choose a sequence from this array. So sequence means we can remove some element, but the order of the remaining elements stays same. Okay, so see, we can choose 1 3 from this array. We can choose 1 3. So we can also choose 2 3, but we cannot choose 3 1 from this array. We cannot choose 3 1 because it's not allowed, because the order has changed. Okay, because the order has changed. Now see, what does the problem wants? After choosing our subsequence, we calculate the XOR. Okay, we calculate the XOR of all the chosen numbers. The XOR result must be not 0, and among all possible subsequence we want the one with the maximum length. So see, so the problem, choose any numbers, choose as many numbers as possible while making sure their XOR is not 0. Okay, so now what is XOR? See, before solving the problem, we need to understand what is XOR. Okay, so XOR is a bitwise operation, just like and or, like that only. XOR. Okay, just like and or XOR. For XOR, the basic rule is, if the basic rule is same is equal to 0, different is equal to 1. Okay, basic rule for XOR. See, for example, 1 XOR 1 is equal to 0, same is 0. Okay, for in see, if 2 in binary 2 look like this, so it was different, so it was 1. Okay, like 1 XOR 0 is equal to 1, same is 0, different is 1. Okay, in like this, 0 XOR 1 is 1, 0 XOR 0 is equal to 0. Okay, but now you may see, but now why are we using 0 and 1? Okay, you will think why we are using 0 and 1, because computer represent number using binary. Okay, now see, what, let's understand what is bits. So a bit is simply 0 or a 1. So normal numbers use decimals like 0 1 2 3 4 5, so on. So computer works with binary only, that was 0 and 1. So numbers can be represented using only 0 and 1. Say for 1 in binary it was 1, binary it was 2, like this. 3 is level, 4 is 100, and 5 is 101. So how do we get this number? See, 1 2 2 double 4 4 double 8. If I want to make 3, how can I make? 2 plus 1 is 3, so I write 1 1. Okay, so see, we get the 3. If I want to make a 4, just like 4 1 0 0 100. Now I want to make 5, 4 1 0 1 1 0 1. That's how we get these numbers. Okay, so see, this all called binary representation. Now see, you will think, let me explain clearly how those 2 and 10 comes. So let's understand with proper example. Binary position have rules like 1 2 4, right? For number 2 we need 2. Okay, that's why 2, it's mean 0. So see, 0 1, it's means 0 into 2 plus 1 into 1 is equal to 2, so therefore 2 is equal to 10. Okay, it may look difficult, but in simple way, if I want to make 2, 1 0. Okay, so it is 10. Now I want to make 3. How can I make 3? 1 1. Okay, 11. Now I want to make 9. How can I make 9? 1 0 0 1. So it was 9. Okay, so now say, now let's calculate 2 XOR 3. Now we know 2 is equal to 10 and 3 is equal to 11. So we write them one below another, like 10 11. So how, now we compare each byte. Okay, 1 XOR 1 is equal to 0, so they are same. So second, they are same, so second one is 0 XOR 1 is 1, so they are different, so the answer is 0 1. Okay, so in decimal, 0 1 in decimal is 1, so this is 0 and 1 in decimal, 0 1 is 1. Okay, so therefore see, now 2 XOR 3 is 1. So let's take one more example. Now let's take 5 XOR 3. So in binary, 5 is 1 0 1 and 3 is 0 1 1. Okay, so it was same, so same is equal to 0 na. Yeah, same is 0, different is 1, so 1 is 1 same, so 0, it was different 1 and it was also different 1, so it 1 1 0. Now we convert this 1 1 0 back to decimal, that was 6. Okay, see, 1 into 4 plus 1 into 2 plus 0 into 1 is equal to 4 plus 2, that was 6. So 5 XOR 3 is 6. Now see, now let's now come back to this problem. So our example is 1 2 3, so we have to try to choose a maximum number of element whose XOR is not 0. So let's first choose everything. 1 2 we calculate, let's see here. So we calculate 1 XOR 2 XOR 3. So first 1 XOR 2 is equal to 3, then 3 XOR 3, that was 0. So 1 XOR 2 XOR 3 is equal to 0. Okay, now but the problem says XOR must not be 0, so this 1 2 3 we cannot use all 3 elements. Okay, so what we do, we try removing one element. We want the maximum length, so if the length 3 does not work, we try length 2. So let's take 2 and 3, we calculate 2 XOR 3, that was 1, so 1 is not equal to 0, so this length, so its length is 2, so the answer is 2. Okay, so that's how we get the answer is 2. Okay, let's take one more example. Let's take nums of array 2 3 4. So first try the whole array, we calculate 2 XOR 3 is equal to 1, then 1 XOR 4 is 5, so 1 XOR 4 is 5, so 2 XOR 3 XOR 4 is equal to 5, so 5 is not 0, so therefore the whole array is valid. Okay, so the answer is 3. So our array length is 3, so the answer is 3. So see, first we are given an array of integers. We need to choose a subsequence with maximum length. After choosing the element, we calculate the bitwise XOR, and this XOR must be non-zero. So XOR is a bitwise operation. We convert the number into binary and compare their bits one by one. If the two bits are the same, XOR gives 0. If they are different, XOR gives 1. Okay, so just we want the longest subsequence. We always try to keep as many elements as possible. Now how to solve this problem? So let's solve this problem. We have numbers of array 1 2 3, so we need the longest subsequence whose XOR is not 0. First we try the entire array. Why? Because we want the longest subsequence. Because we want the longest subsequence, the entire array has the maximum possible length. Okay, so 1 XOR 2 XOR 3 is equal to 0. So the entire array does not work. If the whole array does not work, what makes the array? The whole array has length 3. So if the length 3 does not work, the biggest possible length is 2. So the next biggest possible length is 2. Okay, so we remove one element. We remove 1. Now we have 2 and 3. So 2 XOR 3 is 1. So 1 is non-zero. So the length is 2 and the answer is 2. See, but here the important trick, we do not actually need to try every possible subsequence. Why? Because of a very useful XOR property. Suppose A XOR B XOR C is equal to 0, then A XOR B is equal to C. So that means if the total XOR is 0, we can remove one suitable non-zero element and make the remaining XOR non-zero. So if the total XOR is 0, we can usually get n-1 element, but there is one special situation. So what if every number is 0? See, what if every number is 0? If we have numbers of array like 0 0 0, so whole array is 0 XOR 0 XOR 0 is equal to 0. So we remove one element. So in our array is like 0 0, so same 0 XOR 0 XOR is equal to 0. We remove one more element. Now we have only one element, 0. Same, so there is no way to get a non-zero XOR, so the answer is 0 only. So there are only 3 cases. Okay, case 1 is whole array XOR is non-zero, like this. Say example, case 1 is whole array XOR is non-zero, like 2 3 4. Okay, 2 XOR 3 XOR 4 is 5, so it was non-zero. So the answer is n. Okay, the answer is 3, so we just n. Okay, so case 2 is whole array XOR is 0, but there is at least one non-zero number, like example C 1 2 3. So the whole XOR is 0, but there are non-zero numbers, so we can remove one non-zero number and get a valid sequence. So we do answer is equal to n-1. So now n before our n is 3, after its n will become 2. Okay, we remove this element, so our answer is 2. And third case is what all numbers are 0, like this. Okay, so the answer is 0. So see, when you see the problem, just think like this. We have to calculate, let me write, calculate XOR of the whole array, then is XOR has non-zero s, then answer is n. If no, so is there are non-zero number. Okay, is s, answer is n-1. If no, answer is 0. Okay, so that's the entire trick. So it was a trick. So see, in this problem, why we do not need dp recursion. So because entire problem look like there are many subsequence, so how do I check them all? So what could be but XOR give as a shortcut. See, if we use recursion DP, so there are many subsequence. How do I check them all? So that could be huge, but XOR give as a shortcut. We only need to know total XOR. Does the array contains a non-zero element? That's it. So the solution become extremely simple. So let's write like say nums of array 1 2 3. So total XOR is 0 of this array. Total XOR is 0 of this array, so there is non-zero element, therefore answer is equal to 3 minus 1, that was 2. Okay, that's it. Let's take one more example. 2 3 4. So the total XOR is 5 and 5 is not equal to 0, so the answer is 3. Okay, let's take this example is 0 0 0. Okay, so the total XOR is 0, so and there is no non-zero element, so the answer is 0. Okay, so first we calculate the XOR of the entire array. If it is already non-zero, we can take the whole array. If it is 0 but there is at least one non-element, we can remove one element and take the remaining n minus 1 elements. If all elements are 0, so no valid subsequence exists, so the answer is 0. Okay, now let's write down the code. Let's take this example only. 1 1 2 3. Okay, we already know the 1 XOR 2 XOR 3 is 0, so there is non-zero number, so the answer should be it was pen issue. Okay, wait. 1 2 3. 1 XOR 2 XOR 3 is equal to 0, so there is no XOR, there is no zero number, so the answer should be 3 minus 1, that was 2. Okay, so let's write down the code. See here, we need the total XOR. Okay, first we need a total XOR, so we need to calculate this. So we create a variable. Okay, first, so we create a variable in total. Okay, in total XOR, okay, is equal to 0. So why start with 0? Because here 0 XOR x is equal to x. Now total XOR is 0. Okay, so now go through every numbers. We need to XOR every numbers with total XOR. So that's why we write we for int num. This means take each number from the nums one by one. Okay, like this. See, it's take numbers like this. We have 1 2 3. For the loop, give as num is equal to 1, num is equal to 2, num is equal to 3. Okay, so next we have to calculate the XOR. So inside the loop we write this total is equal to num. Okay, so this is just a shorter way of writing. So this is just a shorter way of writing like this. Total is equal to total num. Instead of we just write total num. Okay, this is just a shorter way to write this instead of this. Now let's try run. So total is equal to 0, so 0 XOR 1 is equal to 1. Now our total is 1. So in second, our total is 1. 1 XOR 2 is equal to 3. So now our total is 3. So third element, 3 XOR 3 is 0. So now total is 0. Okay, so next we have to check the first case. So our first case was, if total XOR is not 0, take the entire array. So that we write, if total is not equal to 0, return size. Okay, for example, our total is 0. So 0 is not equal to 0, it was false, so therefore we do not return here. We move to the next case. So we need to know if any number is non-zero. So we need a variable bool has non set 0. Okay, false. So has non-zero is false. Okay, initially we assume has non-zero is false, then we check every number and noun is to nouns. Inside this, if we check every number and in noun is not equal to 0, let's see, non equal to 0, then has 0 is equal to true, just break. Okay, see, this means if I find even one number that is not 0, I know that a non-zero element exists. Okay, like this here, if we have nums of array 1 2 3, so num is 1 and we check 1 is not equal to 0, so it was true, so non-zero is equal to 1. Okay, then we break, means, see, we already found 1, no need to keep checking. Okay, then we return our answer. Just in the code. Okay, if okay, then we create, see, this way is that non calculate XOR of the entire array. Then this case 1, this one is case 1. Okay, if total XOR is not equal to 0, whole array already has non-zero, then we check if there is at least one non-zero number. Okay, then we break. So see, so case 2 is total XOR is 0 but a non-zero number exists. If has 0, return nouns dot size is equal to -1. Okay, then in just we just return all numbers are 0, return 0. Now let's try run this. So we have nums of array is equal to 1 2 3. So the expected answer is 2. Okay, we know the expected answer is 2. See, first we have write in total is equal to 0. So first I need to calculate the XOR of the complete array. So I create a variable called total. I initialize it with 0. Okay, total with 0. Now we write for int num is to nums, means now I will visit every numbers in the array one by one, like 1 2 3. First time num is equal to 1, then num is equal to 2, or so on. Okay, now first is num is equal to 1, then we write total XOR into num. So it means total XOR is 0 and num is 1. Okay, so we calculate. So now our total XOR become 1. So in next iteration nums become 2. So same total XOR is 1 and nums is 2. So it 1 XOR 2, it's become 3. Now our total XOR is 3. Okay, now num becomes 3. Again it's become 3. Now same it's calculate. Now num is 3. So 3 XOR 3 is 0. Okay, so the total XOR is 0. So the loop is finished. We have total XOR is 0. Okay, you have total XOR is 0. So the XOR of the complete array is 0. So we cannot take the entire array because the problem required a non-zero XOR. So in next we check this. If total is not equal to 0, then return nums dot size. Okay, so now total XOR is 0. So the condition becomes 0 is not equal to 0. Okay, 0 is not equal to 0. So this is false, therefore we do not return here. We continue. Okay, so since the total XOR is 0, the complete array is not valid answer. So I move to the next case, that was bool has non-zero. Okay, so it was false. So see, now I need to check whether the array continue at least one non-zero element. Now our has non-zero is false. So next we for int num is to nums. So again we go through the numbers one by one. First num is 1, then if num is not equal to 0, so 1 is not equal to 0, yes, it was true. So we enter if. Okay, then we enter the if. So now has non-zero become true. So I found a number that is not 0, so I set non-zero, so non-zero to true. So we break here. I already found one non-zero number, so I do not need to check the remaining number. That's why I use break. So the root stop we do not need to check to all 3. Okay, so the non-zero is true, so we continue true. So we return nums dot size is equal to -1. So our array has 3 elements, so n minus 1 is 2, so we return 2. See, why did we return n minus 1? This is the main idea you should understand. Our complete array is 1 2 3. So now its XOR was 0. Okay, so we cannot take 3 elements, but there is non-zero numbers are 1 2 or 3. So we can remove one element and keep 2 3. So 2 XOR 3 is 1, which is non-zero. So we can keep 3 minus 1 is 2 element. Okay, so in last we just return 0. If the total XOR is 0 and there is no 1 0 number, that means every number is 0. In that case, every possible sequence we also have XOR 0, so no valid subsequence exists, therefore we just return 0. Okay, if that example 0 0 0, where is that case? This one, no, this one not. I have just cleared that. So we have take that example, 0 0 0. Subsequence we have 0 and the answer is 0. That okay. So the problem, that's it. So in this problem First, I calculate the XOR of the entire array. If the XOR is non-zero, I can simply take the complete array because it already give me the maximum possible length. If the total XOR is 0, I cannot take the complete array, so I check whether it is at least one non-zero element. If there is, I can remove one element and keep the remaining n minus 1. Okay, we can n minus 1 elements are given as a non-zero XOR. So finally, if every element is 0, then every possible subsequence will also have XOR 0. So no valid subsequence exists, and I just written in last 0. So that's it. So that's the answer.